Welcome back. We are going to continue with transaction logs. We saw recovery model, simple, full, and log recovery model. Now we are going to continue with transaction logs, and every transaction log contains three main components. We have the log sequential number. This one is very essential and very important when it comes to the chain of custody. The chain of custody, yes, it shows the ID and the time span and the ID for that particular action. Now the operation, which operation was carried out during this process, which operation was carried out during this execution or during this attempt. So we have the loop delete, the loop insert, or the loop modify row. Any of the operations could be carried out. Before and after image. So it shows the initial image of the log and the new image, since it doesn't delete any record. So it can show you any record at any point in time, as long as the transaction log was actively recording the data. So it will show you the initial image. Let's say, for example, we have an example here. The salary initially was 30,000. The new salary that was set now was 5,000. So now let's say a delete operation is carried out. You will not see in the table, what in the user interface you will see 0 rows. 0, you will not see the value, for example. But for the log will show you the user X, will show you the email, the user ID, and the value and the time, because transaction log stores value in hexadecimals. So you are going, and it's also going to show you the time in which that action was taking place. So for example, the initial value was 5,000, the initial value was 3,000, and now somebody updated it to 5,000. So it's going to show you the before value, which was 3,000, and the final value, which is the value that will be on the table, will be 5,000. The value that will be on the table will be 5,000, but you only see 5,000 in the user interface. But for the log section, the back end, you are going to see the initial value and the after value. Now, if it's the update function, for example, for the update function, new value is going to show you the update. It shows you the new value that is there. But in the back end, you're going to see the old value, like we're seeing the old value, and you're also going to see the new value. Shrinkation is just emptying the table, like disallocating pages. We saw pages on the two, like database saves data on pages, 8 kilobytes generally. So the table is going to be completely empty, but in the logs it's going to show that the pages were deallocated, and it's going to show you the time in which the event occurred. But this is the general user interface, and this is the back end interface. Now, how do we make recovery process very effective? For example, you say separating. For example, you separate the physical storage, the LDF, the transaction log storage file, from the main data file storage. So you put them in separate files, so that if there is a crash or there is an issue in the file with the LDF, your log files are very much safe, and you can always recover your data with no zero loss. With zero loss, as long as you have your LDF files separate from your MDF files. You implement regular backup. For example, for regular backup, especially for financial systems, 15 or even 5 minutes. For example, you do regular backup. You fill up the visual log files. You fill up space because they are reused. This will make sure that no data is lost. You size the log correctly from the initial start. You know what will be saved for every individual field or every individual table, the data that you are placing in that table. So it saves space and it saves time. So you don't want a continuous increment or 10 times increment. So you have to size correctly the section that you are using for that database. Now, log modification. Now, for log modification, malicious intervention, what you do is that you restrict the access of people having access to the LDF files. So you restrict the access so that specific people cannot get access to the LDF files. So attackers can wipe the table, they will only see this. But one thing they will fail to understand is that the transaction of the LDF files are right in it. They will show you everything that was there, the time, the ID, and everything that happened, even no matter what you do, even if it's a job function. Now, this is the log structure. Every database has a structure. I'll be talking about EF files, their visual log files, and their chunks, They are chunks, they are component of the log structure. When you are inputting the data, inputting data to the inputting data, when the place in which the data is written in small sections, small chunks is the visual log files, and they are in secular use. So you have to always do backup to fill those spaces, to allocate some spaces as inactive so that they can always be overwritten. If you don't do like that, they will accumulate more and they will reduce system performance. So we have the LSA, which is the log sequence number. This one is like the is very important. As we said earlier, it's very important for the chain of custody. It has 3 parts. It shows the unique and the time span. The time span for that particular incident. So and it's having 3 parts. The VF part, 3 segments, the VF, the block, and the segment. You have the log record. One action, you know the rule. One action, one record. And this is sequential. You don't update like the bank teller notes that we used earlier. If there's a problem, you don't cancel, you don't update it. You go straight, you correct the issue only on the next time. It is very sequential, you cannot update it. You can only correct, you only add the need the next time. Now all records get overwritten. So as we were saying, it's the VLF chunks are overwritten, they are always in secular use. So you must always do regular backups to see to store data. If not, if you don't do that, you will never have the data because in the system itself has been programmed to only use those spaces. Now, when we are taking data, especially in the promises, we are saving data. There are 7 things that we are going to collect for every specific entry that we are looking for. For example, the LS, the where and the when every log sequence will happen. The exact ID. The exact ID is simply just going to like group the queries for every specific ID under one query. Let me say one person did different actions. The person updated the row, one ID did different actions. The ID updated the row, deleted, translated, did a lot of things. So it will not show you different. It's just simply going to group all of them as one query and return it under that specific ID. Now loop operation is just showing you different operations that we're taking, like insert, delete, modify row, or delete at anyone. Allocation unit is simply going to show you what segment of the database was targeted, what segment of the table was targeted. Was it a table or was it the index? What segment of the table, which segment of the index was targeted? That's all. Why this transaction is just going to help us to catch who, because when we use this function, we can actually get the name of the person who did the action. Now the beginning time is just telling when the action started, and the before and after image we have the same row of content, so the initial value and the row of content of the new updated faulty value. Now these are the role in crime, what each function does. This one is actually very important. Begin when the scene started. Instead, those are just the operations, the attack or change. Commit is very important in forensics and investigation, in that when somebody commits, it means you have saved the act. You have saved the act. So it is important, even if when you do it and you commit it means it wasn't a mistake. You did it and you finalize the act. That is the meaning of commit. Not the improve that you actually finalize the act. Why abort is simply that you did the act, but due to some constraints or system restrictions, you didn't finalize the act, but you actually initiated the act. Why VLT translation is CCTV reviews. It tells us if there's a missing evidence, for example, it's going to tell us that okay, because the VLF were all overwritten or they were all used up. That's why you have to do regular backup, because we all know that these VLFs are used and they are used, so they are always overwritten. So you always have to do regular backup to create inactive ones that can be removed. So it tells us if why there's a missing data if they was not active VLFs. Now this one is just mass. If the person actually used a very massive high level deletion tools like mass deletion tools and just wanted to like scatter the entire database system. So transaction logs are in 2 types. We have the active log and we have the inactive log. The active log is the one that cannot be overwritten. It has programs that are still running. So and they have not been safely written down to the main file. So this one cannot be overwritten. But inactive log, it contains finalized finalize logs that have already been written. And this one, when the checkpoint area has already been completed, the data now can come now to the inactive logs. I think that's all for this section, and we are going to see you in the next class. The next